Okay, ladies and gentlemen, back. Section 7.5 is solving rational equations. Um, and the steps to solving rational equations, first of all, we have to factor all denominators. Just when you thought your factoring skills were done. After you factor your denominators, you build all your fractions up into equivalent fractions, just like we did in the last section when adding or subtracting rational expressions. And then once we do that, basically what we do is we just wipe away the denominators. And then we just solve the equation left behind. And then the last thing is you want to check for any violations of any restrictions imposed on the equation. And so, ladies and gentlemen, back up here, once you factor all your denominators, we should put another thing in here in between these two steps where we want to basically indicate any restrictions. On the equation. And the reason why we need to check for any restrictions is because, remember, when you have a rational expression, you got to make sure you never divide by zero. If you are dividing by zero, your whole equation becomes undefined. And so this checking for restrictions actually dates way back to section 7.1. All right, but those are the steps in solving rational equations. Let's dive right in here and begin. So the instructions go from adding or subtracting rational expressions to solving rational equations. So we have x over 2 plus 4 over 3, and that's equal to negative 2/3. Notice all of our denominators are just numbers. There's no variables in any denominator, and all these denominators are factored. And so for that being the case, there are no restrictions placed on this equation in the sense that you could never assign any numeric value for x such that any denominator would become 0. And so we're never going to have to worry about this equation being undefined by dividing by 0. So being the case, we can now put together our least common denominator, which is going to be the smallest number or the least number divisible by both 2 and 3, and that's going to be 6. So 6 is our least common denominator. The next step now is to build all of these fractions in this equation up into equivalent fractions that take on the least common denominator of 6. The first rational expression in this equation, this rational equation, ladies and gentlemen, is a 2. And in order to build a 2 up to a 6, the least common denominator, we're going to have to multiply top and bottom of this first fraction by 3. In order to build the second rational expression's denominator up to the least common denominator of 6, we're going to have to multiply top and bottom of the second rational expression by 2. In order to build negative 2/3 up into an equivalent fraction that has 6 for its denominator, we're going to have to multiply the negative 2/3 top and bottom by 2. Hence, our equivalent rational equation is going to be 3x over 6 plus 8 over 6. And that's going to be equal to negative 4 over 6. And so now, ladies and gentlemen, what we got going on here is we have an equivalent rational equation. Notice all the denominators are the same all the way across in our equation. And now the next step says that once we get equivalent fractions with the common denominator, we can wipe away our denominators. How can we just wipe away our denominators? What makes this step legal? Well, what makes this step legal is if I was to now multiply both sides of my equation by 6, we would see that through cross-canceling, if I was to multiply every one of these fractions by 6, we would see that by cross-canceling, all the denominators would be wiped out. And so instead of going through this step here, all we have to do is just remember that when we get equivalent fractions that all have the common denominator all the way across in our equation, the shortcut is to just wipe away all your denominators. Just get rid of them all. And now we're going to have to deal with just solving the equation that remains, which is to say we solve 3x plus 8 equal to negative 4. So this is the equation that needs to be solved, and now we're back to an old school type of equation. We're used to these types. Subtract 8 from both sides. 8's drop out on the left, leaving you with 3x, and on the right we have a negative 4 subtract 8, which is negative 12. And then finally, ladies and gentlemen, we're going to divide both sides of our equation by 3. And we do get x is equal to, negative 4. Okay. So therefore, our solution to this rational equation is negative 4. And we are done. All right, let's try another one. Here we have a rational equation, and notice this 3 could easily be placed over 1, no harm done. Notice all our denominators are factored. Ladies and gentlemen, since we do have a variable appearing in at least one of our denominators, we need to think about any restrictions that has to be imposed on this equation so that it remains defined. And notice, since one of our denominators, both these denominators have an x in them here, we got to make sure that this x is never equal to 0. Because if x is equal to 0, we will be dividing by 0, and that's an undefined operation in mathematics, in which case the whole equation would be undefined. So one restriction imposed on this rational equation is the fact that x cannot be equal to 0. All right. So now the next step is, what is the least common denominator of x, 1, and x? Well, you guessed it. It's just x. So x is the least common denominator. The next step is now to build all these fractions up into equivalent fractions that all take on the least common denominator of x. Good news. 2 of the 3 fractions already have the least common denominator of x, so we don't have to do anything to them. The second fraction needs some help, though. In order to build its denominator up to x, we're going to have to multiply the denominator by x, which means we have to also multiply the numerator by x to maintain an equivalent fraction. So the second fraction, top and bottom, gets multiplied by x. Notice the fraction on the right side of the equation already has the least common denominator. Just bring it along. So this is your equivalent rational equation now, where we do have a common denominator throughout. And now the next move, ladies and gentlemen, is to just wipe away these denominators. And that can be, that's legal, of course, if we were to multiply both sides of this equation by x. So we just wipe these away, and we're left with this equation to solve. So now this is the equation that we have to solve. And so now we're back to a familiar type of situation. We subtract 4 from both sides. 4's drop out on the left. 1 subtract 4 on the right is negative 3. Divide both sides by 3, and we get x is equal to negative 1. Notice our solution x equal to -1 does not violate any restriction that we had to initially impose on this rational equation. And because of that, ladies and gentlemen, we would keep this as this, we would retain this as our solution, and we're done. So x equals -1 is the solution to this rational equation. All right, let's try another one here. All right, we'll try to solve this one. 3 over y minus 4/5 is equal to -1/5. Because at least one of our denominators contains a variable, we need to think about any restrictions placed on this rational equation so that it remains defined. So we got to make sure that this denominator of y never becomes 0. So therefore, one restriction placed on this entire equation is to say that y cannot be equal to 0. So let's note that restriction over here. So therefore, y must never be equal to 0. Okay, now our least common denominator of this rational equation is going to have a 5 in it, and it's going to need a factor of y. So 5y is the least common denominator of all these denominators here in this entire equation. The next move now is to build these fractions up into equivalent fractions that all take on the common denominator of 5. The first fraction, top and bottom, has to get multiplied by a 5. The second fractions, top and bottom, must get multiplied by a y. And the fraction on the right side of our equation, top and bottom, has to get multiplied by y. Notice now we have a common denominator all the way across. Now that we have a common denominator all the way across in our equation, we can just wipe out these denominators all the way across, and we're left with this equation to solve. So this is the equation, ladies and gentlemen, that is in need of solving. 3 times 5 is 15. I'm going to add 4y to both sides of my equation. Take the variable y over to the right side of the equation. The y's drop out on the left side or cancel out to 0, leaving you with 15. And on the right side, we have -1y plus 4y is 3y. Divide both sides by 3, and we get our solution, which is y is equal to 5. Notice 5 does not violate the restriction placed on this rational equation initially, and because of that, we retain this as our solution, and there is your answer. If, ladies and gentlemen, we went through this entire solution process for this equation, and we got a solution of 0, we would have to toss 0 out as being a solution because 0 violates our restriction placed on the equation back up here. And in such a case, if we did have to do that, we would say this equation has no solution. But we didn't get that. We got 5, which is our solution, and it does not violate our restriction, so 5 remains as the valid solution to this rational equation. All right, let's move the bar up a little bit here. Try to solve this one, x minus 2 over 3 plus 5x over 2 equals 5. To solve this rational equation for x, notice we don't have any variable x appearing in any denominator. This 5 could be placed over 1. And so there are no restrictions necessary on this rational equation. Next move is to find our least common denominator. Notice all our denominators are completely factored. So therefore, the least common denominator of 1, 2, and 3 would be 6. What remains now is to build all these fractions up into equivalent fractions that all take on the denominator of 6. The first fraction's denominator is 3. It must be multiplied by 2. So that must mean the numerator must be multiplied by 2. The second fraction's denominator is 2. To make it a 6, the denominator must be multiplied by 3. So top and bottom of the second fraction must get multiplied by 3. The fraction on the right has a denominator 1. To make the denominator 6, top and bottom of the fraction on the right side must get multiplied by 6. All right, so what are we going to have here? Well, now we're going to have 2 times quantity x minus 2 over 6, plus 5x times 3 is 15x over 6. 5 times 6 is 30 over 6. And now that we have a common denominator all the way across in this rational equation, we can just basically wipe away all our denominators. And that would be the case if we were to multiply both sides of this equation by 6. All these denominators would be wiped out. And then we're left with this equation that we're going to have to solve. So this is the equation that we're now going to have to solve. So we're back to a run-of-the-mill equation that we dealt with in the past. We have to distribute on the left side of our equation. Then we combine like terms on the left side. 2x plus 15x is 17x. Add 4 to both sides. And then divide both sides by 17. And these 17s reduce out here, and we're left with x is equal to 2. 34 divided by 17 is 2. And that would be your answer. So 2 is the solution to this rational equation up here. And we're done with that problem. Alright, we have 3 over x minus 1 plus 2 over x plus 3 is equal to negative 3 over x squared plus 2x minus 3. So here is a rational equation, and we want to solve the rational equation for x. Notice that some of our denominators, namely the last denominator over here, is in need of factoring, so we need to completely factor this trinomial first before we go any further with this problem. Notice this is an easy type of trinomial to factor, one with a leading coefficient of 1. All we need are 2 factors of the negative 3 here that sum up to positive 2, the middle coefficient. The only factors of negative 3 that add up to 2 would be 3 and negative 1. So therefore, this trinomial now factors into x plus 3 times x minus 1. Now, ladies and gentlemen, since we do have a variable x appearing in at least one of our denominators, we need to think about any restrictions that need to be imposed on this equation. And so we got to make sure that none of these denominators ever become 0, because if any denominator becomes 0, we will be performing a division by 0, in which case the entire equation will be undefined. So in order to ensure that this denominator is never 0, we got to make sure that x minus 1 is not equal to 0. So here's our restrictions. So x minus 1 better never be equal to 0, which means that when we solve this, we add 1 to both sides, which means that x better never be equal to 1. That's one restriction placed on this equation. But we got to make sure that this denominator never becomes 0. So therefore, take x plus 3, set it not equal to 0, and then solve this by subtracting 3 from both sides. We get x better never be equal to negative 3. There's another restriction imposed on our equation. Notice, in order for this denominator to never be 0, since we already dealt with x plus 3 not being equal to 0, x cannot be equal to negative 3, or x cannot be equal to positive 1. We already dealt with that earlier. So we have all the restrictions placed on this rational equation here. X can never be equal to 1, or x can never be equal to negative 3. Now the next move is, ladies and gentlemen, we need our least common denominator for this rational equation. And what are we going to need for our least common denominator? Well, we're going to need one factor of x minus 1. And we're going to need a binomial factor of x plus 3. So this would be the least common denominator of this rational equation and all of its denominators. The next move now is we got to make sure that we build this rational expression up into all these rational expressions up into equivalent fractions. The first fraction has the x minus 1, but it's missing the x plus 3. And because of that, the first fraction, top and bottom, gets multiplied by x plus 3. The second fraction has the x plus 3, but it's missing the x minus 1. So top and bottom of the second fraction in this equation gets multiplied by x minus 1. Notice the fraction on the right side of the equation already has the least common denominator. So we don't have to do anything with this fraction on the right side. Now that we have a common denominator throughout our entire equation, we can wipe away all these denominators, get rid of all of them, and the equation that we need to solve then is found in the numerator. So therefore the equation we're going to have to solve is 3 times x plus 3 plus 2 times x minus 1, and that's got to be equal to negative 3. So this is the equation now that we're going to have to solve for x. And to do so, we're going to have to distribute not once, but twice. So we have 3x plus 9 plus 2 times x is 2x. 2 times a negative 1 is minus 2. And that's your equation that we have to solve. Combining like terms on the left side of our equation, 3x plus 2x is 5x. 9 minus 2 is plus a 7. And this is the equation that we have to solve. To solve for x, we subtract 7 from both sides. Divide both sides by 5. Hence, this implies that x is equal to negative 2. Notice, negative 2, our solution to this rational equation, does not violate any of the restrictions placed on the equation. And because of that, we keep negative 2 as our solution, and we call it quits. So this is your only solution, ladies and gentlemen, to this rational equation that we started with up here. All right, almost done. Solve a couple more. Okay, hold on a second. I wanted 2 over a squared minus 1, and that's equal to 6 over a squared minus 2a minus 3. All right, here we have a rational equation, and we want to solve this equation for a. Notice that both these denominators look like they're in need of being factored, so we need to factor completely these denominators. Notice a squared minus 1 is a binomial. It happens to be the difference between perfect squares, so it factors into a plus 1 times a minus 1. This trinomial denominator on the right-hand side is an easy type of trinomial, one with a leading coefficient of 1. All we need are two factors of negative 3 here that sum up to the middle coefficient of negative 2. And the only factors of negative 3 that work are going to be negative 3 and positive 1. Being the case, this trinomial immediately factors into a minus 3 times a plus 1. A minus 3 times a plus 1. Notice we do have a appearing in at least one of our denominators. Being the case, we're going to have to think about any restrictions imposed on this rational equation so that it remains defined. In order for this denominator not to ever be equal to 0, a plus 1 and a minus 1 better never be equal to 0. So a plus 1 better never be equal to 0, which is implying that a better never be equal to negative 1. There's one restriction. A minus 1 never better be equal to 0. So a minus 1 not ever being equal to 0 implies that a better never be equal to 1. Another restriction. A minus 3 better never be equal to 0. which is to say that a better never be equal to 3, or a plus 1 never better be equal to 0, but we already dealt with a plus 1 not being equal to 0, which is saying a cannot be equal to negative 1. So these are all the restrictions, ladies and gentlemen, that are placed on this rational equation. A better never be equal to 3, or 1, or negative 1. Because if a takes on any of these values, then this rational equation is undefined, because if a takes on any one of these values, then at least one of our denominators in the equation becomes 0. And we will be performing division by 0, and division by 0 means undefined. Okay, now the next move is to find our least common denominator. And what would be our least common denominator? Well, our LCD is going to need one factor of a plus 1. Going to need an a minus 1. And it's going to need an a minus 3. So that's your least common denominator. You must have all these factors present in your LCD. The next move is to build these fractions now up into equivalent fractions that both take on the least common denominator. The first fraction has a plus 1, and it's got the a minus 1. It's missing the a minus 3. Because of that, top and bottom of this rational expression on the left side of our equation gets multiplied by a minus 3. The fraction on the right side has the a minus 3. It's got the a plus 1. It's missing the a minus 1. So the fraction on the right side gets multiplied by a minus 1. There we have it, ladies and gentlemen. Now that we have a common denominator all the way across in our rational equation, we can blot it out or wipe it away, and we're left with this equation to solve. 2 times a minus 3 is equal to 6 times a minus 1. So this is the equation that we now have to solve. To do so, we have to distribute on the left side of our equation and the right side of our equation. Hence, we'll have 2a minus 6 is equal to 6a minus 6. Now, to solve this equation for a, I'm going to drag the a over to the left side of my equation by subtracting 6a from both sides. And I'm going to drag the negative 6 over to the right side of the equation by adding 6 to both sides. 2a minus 6a is negative 4a. These 6's drop out. 6a's drop out on the right side of our equation, and negative 6 plus 6 yields 0 on the right side of our equation. Notice we'll now divide both sides of our equation by a negative 4. And therefore this implies then that a is equal to 0. So a is equal to 0 here. And that's it, ladies and gentlemen. It looks like our solution to this rational equation is 0. And notice 0 does not violate any restriction that we placed on the equation initially. So this rational equation has been solved, and the solution is 0. Okay. All right, one more. All right, this is the rational equation we want to solve, and of course we have to make sure that all your denominators are completely factored. Notice x minus 4 is completely factored, x minus 3 is completely factored, but this trinomial is in need of factoring. So we need to completely factor this trinomial. Now, as I'm two factors of positive 12 here that add up to negative 7, the middle coefficient would be negative 3 and negative 4. So now that we found two factors of this constant term that sum up to our middle coefficient, this trinomial factors into x minus 3 times x minus 4. Now we can put together our least common denominator, and our least common denominator is going to need one factor of x minus 4. It's going to need a factor of x minus 3. So this would be your least common denominator of all your denominators here. Now it's time to build all these fractions up into equivalent fractions that all take on the least common denominator. Notice first denominator has the x minus 4, but it's missing the x minus 3. And because of that, top and bottom of this fraction here on the left side of our equation must get multiplied by x minus 3. This fraction on the right side, 2x over x minus 3, has the x minus 3, but its denominator is missing the x minus 4. And because of that, top and bottom of this fraction gets multiplied by x minus 4. Notice this fraction has everything it needs in its denominator to be the least common denominator. So we don't have to do anything to this fraction here. Just bring it on down. Now that we have a common denominator all the way across our equation, we can just basically wipe away our denominators, get rid of all of them, and we're left with the equation in the numerator to solve. So we're left with this equation. So this is the equation that we have to solve. We distribute the x inside the parentheses here. So 3x times x is 3x squared. 3x multiplied by a negative 3 is a minus 9x. 2x gets distributed into both these terms here. 2x multiplied by x is 2x squared. 2x multiplied by a negative 4 would be a minus 8x plus the 6. Okay, ladies and gentlemen, now we have what's called a quadratic or second degree polynomial equation to solve. To solve this equation, we're going to have to get it set equal to 0. So we're going to have to drag everything over to the left side of this equation in order to zero this equation out. So we're going to have to subtract 2x squared from both sides. We're going to have to add 8x to both sides. And we're going to have to subtract 6 from both sides. 3x squared minus 2x squared is 1x squared. Negative 9x plus 8x is minus 1x. And we got the minus 6 that we had to subtract also from the left side of our equation, so it's just a minus 6. The right side of our equation goes to 0 as everything cancels out. And so now this is the equation that we have to solve. In order to solve this equation for x, we're going to have to completely factor the left side of our equation. Notice we have an easy type of trinomial to try to factor on the left side of our equation. So all we need are two factors of negative 6 that sum up or add up to negative 1, the middle coefficient. And those factors are going to be negative 3 and 2. Being the case, this left side of our equation factors into the two binomials of x minus 3 multiplied by x plus 2. Next step now is to set both these factors equal to 0 and then solve the resultant equations. So, solving x minus 3 equals 0 by adding 3 to both sides, we get x is equal to positive 3. And this last equation, to solve for x, we subtract 2 from both sides, in which case we get x is equal to negative 2. Now, ladies and gentlemen, you know what I forgot? Initially, with this rational equation, I forgot to state any restrictions that should be placed on this rational equation. You know, it doesn't matter if you do that at the beginning or the end. So let's look at some restrictions that must be placed on this equation for it to remain defined. I'm going to look at the rational equation where all of our denominators have been completely factored. In order for this denominator never to be equal to 0, x minus 4 better never be equal to 0. So x minus 4 better never be equal to 0, which is to say when you add 4 to both sides, x better never be equal to 4. That's one restriction. In order for this denominator to never be equal to 0, x minus 3 better never be equal to 0. Hence, x minus 3 better never be equal to 0, which when you add 3 to both sides of this thing, that's implying that x better never be equal to 3. And notice, in order for this denominator never to be equal to 0, x minus 3 better never be equal to 0, which means x better never be equal to 3, or x minus 4 never better be equal to 0, which means x never better equal 4. All right, so those are the restrictions, ladies and gentlemen. Again, you could have imposed these restrictions at the beginning of your solution process. I forgot, so I did it at the end. But it doesn't matter whether you do it at the beginning or the end. Now, check this out. Notice when we solve this rational equation, we got a solution of 3. Well, ladies and gentlemen, 3 violates this restriction here. So we have a violation here. Because we said that x can never be equal to 3 for this equation to be defined. And because of that, we have got to take the solution of x equals 3, and we have to toss it out. It cannot remain as a solution to our rational equation. Notice our second solution we arrived at for the equation was -2, and -2 does not violate any of these restrictions. So the only solution to this equation is only -2. So make sure you check your solution or solutions with any restrictions you place on your equation, because if you do get a violation, you're going to have to toss out that solution. So the only solution to this equation is -2, not 3. So we're done with this problem. Well, I hope you enjoyed this section, ladies and gentlemen. You can see that these problems are kind of tedious. They require a lot of paper, patience, and perseverance. Practice is the only hope. You're going to have to just spend time with these problems. I will give you an appreciable amount of practice through the textbook homework and the activities. Please do stay up with this work. If you ever have any questions or would like me to go over any problem, let me know via email. I hope everything is going okay with you. Hopefully you and your loved ones are remaining healthy and safe. Just remember to try to limit our travel and stay around camp and save lives. Take care.